Are you taking an advanced chemistry exam because the only way to get college credit is through greedy corporations? Well, you're in luck because I'm here to give you the big ideas of advanced placement chemistry. Here we have an atom. These are the building blocks of matter, but I think we're going to need more than that. Perfect! There are only a limited number of types of atoms called elements. These are determined by the number of protons in the atom. Atoms can combine together in a different arrangement for a different purpose. We're still going to need more atoms, so we need to find a better way of showing that we have a lot of them. This is where Avogadro's number comes in. Avogadro's number is approximately 6.022 times 10 to the 23rd. This number also happens to be the number of atoms needed to make their atomic mass units, as determined by their protons and neutrons, into grams. It's more cumbersome to constantly use Avogadro's number, so we'll call 6.02 times 10 to the 23rd atoms a mole of atoms. Now that we know how to use Avogadro's number, we can use this to freely convert between atoms, moles, and mass. Let's set up a situation where we're given a rock with a mass of 100 grams, and we are told that the rock is 30% gold. Using the original mass of the rock and our given percentage, we can find the grams of gold within the rock. Taking 30% of 100 grams gives us 30 grams of gold. If we wanted to find the moles of gold in the rock, we could divide this by gold's gram molar mass. This will give us about 0.1 moles of pure gold in the rock. Now that we know how to find moles, we can find what's called an empirical formula, or simplified formula, of a compound, when we're given the percent by mass of each element included. An empirical formula, however, cannot always tell us the exact formula, just an approximation. As for atoms themselves, they contain a nucleus made up of protons and neutrons, and an electron cloud around it containing, well, electrons. Atoms are too small to see with the naked eye, so to help visualize them, we use models. The generally accepted models can change in time. For example, we used to think that atoms were very much like pudding cups. Protons and electrons have a positive and negative charge respectively. These charges have attractive and repulsive forces, which can be calculated. Coulomb's law of electrostatics states that the force of the attraction in newtons can be found by multiplying the magnitude of each charge in coulombs, dividing by the radius squared, and then multiplying by Coulomb's constant, which is 9 times 10 to the 9th newtons times meters squared divided by Coulomb squared. Since the law is an inverse square law, when you double the distance between the charges, you cut the force by a fourth, not a half. Electrons can also leave an atom. The amount of energy required for an electron to leave an atom is known as an ionization energy. The amount of energy is generally determined by the number of valent electrons in an atom. The more valent electrons, the more energy is required to make an electron leave the atom. Electrons within the electron cloud don't follow a specific orbit, as the Bohr model may have you believe. Instead, they follow orbitals. 2 electrons can occupy an orbital at any time. Every electron has a spin, and 2 electrons in the same orbital have opposite spins. Electrons aside, protons also have properties of their own as light waves. The energy of light can be shown by the equation E equals hv, or the frequency of the wave multiplied by Planck's constant equals the amount of energy. The speed of light can also be calculated by an equation of c equals lambda v, or the distance of the light wave times the frequency. The speed of light is constant at around 2.998 times 10 to the 8th meters per second. The periodic table can tell us just about everything we need to know about any specific element. It can tell us the number of valence electrons, among other general trends. Along a period, or row, the first ionization energy increases with more electrons, the atomic radius decreases with more electrons, and the electronegativity, or attraction force, increases. You should remember PV equals nRT from your intro chemistry class, and I hope you do, because we're going to expand on that idea. Firstly, we can use Pivner to find density of a gas, or even vice versa. To do this, we have to remember that moles equal the total grams divided by the gram molar mass. So we can plug this into N. Use some algebra, and we have our new equation for density. The density of an ideal gas equals the pressure times the gram molar mass divided by RT. Another concept regarding gases to understand is Dalton's law of partial pressures. Since gases behave independently, if we put 2 gases in the same container, the total pressure exerted on the container equals the 2 pressures of the individual gases added together. Say we had a super durable balloon, and we filled it with 2 atmospheres of pressure with oxygen, and then we put in 1 atmosphere of pressure with nitrogen. The total pressure in the balloon is 3 atmospheres, because the oxygen and nitrogen don't interact. They basically just pass each other by and ignore the other. And that's the beginning of AP Chemistry. Good luck out there.